Good afternoon, guys. My name is P. Shankar, and we will discuss the topic about the advanced relationship in structural modeling in the subject of object-oriented analysis and design. Review: basic OOAD relations are association, aggregation, composition. In association, represents structural relationship where objects are connected. There indicates a general relationship between two classes, allowing objects of one class to link to objects of another classes. And the main key aspects of the association is can be unidirectional or bidirectional. And another one is often denoted by a simple line between classes. And now we will see aggregation. Aggregation is a special type of association representing a has a relationship where one class continues another. The contained object can exist independently. And the main key aspects of aggregation is part can exist without the whole, represented by a wholly diamond at the whole end. And now composition. A strong form of aggregation implying a part of relationship where the contained objects cannot exist without the container. If the composite object is destroyed, its parts are also destroyed. And the main key aspects are part cannot exist without the whole, represented by a solid diamond at the whole end. And beyond the basics, navigating generalization sets. Generalization, commonly known as inheritance, allows a class to inherit attributes and methods from another classes. A general set further organizes this relationship, providing constraints on how subclasses related to a superclass. Disjoint constraint and overlapping constraints, complete constraints, incomplete constraints. Now we will say disjoint constraint. Ensure that an instance of the superclass can be belong to most of the subclasses in the set. Now overlap between subclasses. And now we'll see overlapping constraint. Allows an instance of the superclass to belong more than one subclass simultaneously. Subclasses can commonly share instances. Complete constraint states that every instance of the superclass must be an instance of at least one of the subclasses in the set. No instance exists solely as the superclass. Incomplete constraints permits instances of the superclass that are not at the specific of the subclass. The generalization of is also covered all possibilities. Advanced dependencies, usage, trans, and refine. Dependencies in OOAD represents relationships where a change in one model element affects another. Beyond the basics, users dependency. Advanced types of often specify semantic meanings crucial for managing complexity in large systems. And now we will see three: user dependency, trans dependency, refine dependency. In user dependency, indicates that one element requires another for its correct implementation or functionality. Often seen when one class invokes an operations of another. For example, a client class uses a service class, represented by a dashboard arrow pointing from the client to the supplier. Transdependency. Establish a historical or informational connections between model elements, usually across different models or levels of abstractions. Link required to its design implementation. Helps maintain traceable throughout the development of life cycle. Define dependency. Shows that one model element is more detailed or precise specifications of another, often used to connect an abstract concepts to its concrete realizations. And it connects a conceptual model to the logical model, indicates the step-by-step process. And now connectors and ports decomposing complex systems. In compound-based design, connectors and ports are virtual for defining the interaction between points and communication pathways and between different parts of the systems, enabling modularity and reusability. Ports, there are two: ports and connectors. In ports, defined interaction points on a classifier of a part. They specify the service that a part provides to its environment and the services it requires from its environment. But compared to connectors, The connectors will link two or more paths together or a path to its containing classifier. They represent the communication between paths through their ports. On ports, there are certain points provide a clear interface for components, can be exposed interfaces or required interfaces, promotes encapsulations and reduce coupling. In connectors, it defines the actual communication channels, can reference various communication mechanism, example like a method call message queue, essential for assembling systems from individual components. State missions and interaction dynamic relationship. While structural diagrams describes static aspects, state mission diagrams and interaction diagrams like sequence or communication diagrams capture the dynamic behavior and relationship within a systems over time. System mission diagrams model the behavior of a single object, showing the sequence of the states an object goes through in response to events and the transitions between these states. Condition during the lifetime of an object, and transitions is movement from one state to another triggered by an event is occurring that can trigger a transition. In interaction diagrams, illustrate the flow of control and data among objects. They focus on the sequence of the messages exchanged between objects to perform a specific function. In sequence diagrams, shows messages in time order sequence. Communication diagrams focus on object link and message flow. Package diagrams organizing large scale models. Package diagrams are used to organize model elements into logical groups called packages. To manage complexity in large systems, they shows the dependency between these packages, helping to visualize the system's architecture to at a high level. There are four: encapsulation, package dependencies, layered architecture, scalability, and maintainability. In encapsulation, packages encapsulate model elements, reducing complexity by hiding internal details and exposing only necessary interfaces. And package dependencies are indicates that changes in one package might affect another. They are often represented by a dash arrow from the dependencies packages to the independent one. Layered architecture facilitates the design of the layer architecture where each layer represents a package with specific responsibilities and dependencies. And scalability and maintainability improves the scalability and maintainability of the package diagrams and providing a clear structure and reducing the coupling between the system's components. Practical applications, case study in system design. Let us consider a practical example. Designing a new feature of our online e-commerce platforms. We will apply the advanced relationship discussed to illustrate how they contribute to a robust and well-structured design. Generalization set in product classifications. Defining a hierarchy of products, examples electronics, apparel, with specific attributes using disjoint and complete constraints to ensure proper categorization. Dependencies in order processing. Modeling how order services use a payment gateway and uh, tracing requirements from customer checkouts to backend services. Ports and connectors for microservices. Designing interaction between independent microservices like innovative management and shipping services using clear defined ports and connectors for their APIs. State missions for user session. Modeling the life cycles of user session, example logged in, browsing, authenticated, checked outs, and the events that trigger transitions. Package diagrams for e-commerce model. Organizing the entire platform into packages such as user management, product catalog, order fulfillment, and payment process, showing their interdependencies. And now we will conclude that mastering the advanced structure modeling is in OOAD goes beyond association, enabling architecture and developers to design a sophisticated resilience and understanding systems. By leveraging the generalization set, advanced dependency ports or connectors, dynamic relationship, and package diagrams, we can efficiently manage complexity and build high quality softwares. And the key takeaways of mastering advanced data structure modeling is precision in relationship uses specific dependencies steps us to convey exact semantic meaning, and modularity through interfaces. Ports and connectors are critical for compound-based designs. Dynamic behavior. State missions or interaction diagrams are essential for understanding how systems evolve. And this is about the advanced relationships in structural modeling. I hope you understand the topic. So thank you.